Imagine a stationary world, ancient, about 4.5 billion years old. It is barely warmed by the sun's rays and covered with a thick layer of ice. This world is smaller than our moon, but slightly larger than Pluto. Its name is Europa, the sixth moon of Jupiter, and one of the largest satellites in the solar system. But what is most interesting about this distant place is that it may harbor life, according to astronomers. Europa is considered. At least, this is how it happens on Earth. If similar processes exist on Europa, it could indicate the presence of subsurface water. However, the temperature, pressure, and chemical composition on Europa are entirely different, and scientists still don't know how the ice behaves there. Therefore, they cannot understand the depth or size of the water pockets or the time required for freezing. However, it is clear that such a subsurface environment on Europa, and where did it go? Another Martian mystery involves microbes that may be dormant beneath the surface of Mars. They could have sought refuge from cosmic radiation for millions of years. Scientists simulated conditions on Mars in laboratories to test whether this could be true, and they were amazed to discover that bacteria easily survived in such conditions for 280 million years. This means that if life existed on Mars, volcanic eruptions, storms, explosions of minerals on the surface, or when meteorites enter the atmosphere. However, there cannot be as much phosphine as astronomers have calculated, and this should have raised suspicions among scientists. But they were too delighted with their discovery. Perhaps they believe that life may exist on Venus. However, even if this gas was created by some mysterious organisms, it remains a big question how they survived on Venus, in the planet's southern hemisphere. It is nearly 8 kilometers taller than the surrounding clouds and almost 1.5 times wider than our planet. In 2017, space probes such as Voyager and Juno gathered a lot of information about the Great Red Spot. It turns out to be a monstrous storm that extends 322 kilometers deep into the planet's atmosphere, which is 30 to 100 times deeper than any ocean on Earth. Scientists faced numerous challenges when trying to unravel the mystery of the Great Red Spot. It is unknown what fuels this vortex. It may be something within the planet itself. Being a gas giant, Jupiter lacks a solid surface, so there is no friction, the only phenomenon capable of weakening the vortex. The hot gases in the planet's atmosphere are constantly in motion, rising, descending, and swirling, massive thunderstorm system. The size of the storm can produce lightning flashes more than 10 times per second. But the main mystery of the Great White Spot lies in its energy source. Some scientists believe it can draw energy from the sun, while others claim that the structure of the thunderclouds only makes sense if there is an internal heat source powering the winds. Nevertheless, powerful vortices exist on different planets
that maintains everything needed to create life and doesn't let anything harmful in. How did the atmosphere form? Earth has cooled down, but the volcanoes are still active. Due to this volcanic activity, water evaporates, turning into clouds, which then turn into rain. For millions of years, rains fall to Earth's surface, pooling into lakes, then seas and oceans. And this would not have given something more complex a chance to develop. The single-celled organisms that existed then were prokaryotes. The main difference between them and us is that their organism oxygen came to exist in sufficient quantities to begin to form the atmosphere in which we now live. And then, within a billion years, somewhere between 3.5 and 2.0 lasted 500 million years. The second, the Huronian Ice Age, was slightly shorter, but it almost exterminated life on Earth. The Huron glaciation lasted 300 million years. It was caused by an oxygen catastrophe. It happened due to the fact that thanks to photosynthesis, unicellular organisms began to release so much to evolution, resulting in the next prototype of modern nature, mushrooms that grow on land. 540 million years ago, the Cambrian explosion occurred. Characterized 70 to 80 million years later, another rapid leap in evolution takes place, and most of the species known to us today come to existence. The first animals to set foot on dry land were arthropods. At first, they simply roamed the land in search of more satiating food than algae and plankton, but then they never went back into the water. According to scientists, one of the most interesting species that transition from life and learn to reproduce by seeds spread across the land and more. The insects will soon fly into the air. Amphibians, having evolved into four-legged tetrapods, remain on dry land, having learned to hide their eggs from predators and eat a variety of foods. In the future, these animals branch out into several species, giving rise to lizards, birds, artiodactyls, and primates, has finally conquered the land. Let's sum it up. Earth has a unique combination of factors contributing to the origin of life. The question about the origin of life remains unanswered, but we have some intriguing clues. Water and the world's oceans are the main source of these answers, but not the only source. Our oceans are unique. They are a result of Earth's planetary evolution. Consists of oxygen. Sounds familiar, doesn't it? That's why today we'll tell you about a place that's almost literally in our backyard, right in the solar system. We are heading to Jupiter to discover the depths of its icy moon, Europa. Europa is one of Jupiter's 7 satellites. It was discovered in 1610 by the famous astronomer Galileo Galilei, along with 3 other satellites that are now referred to as the Galileo satellites. Back then, this discovery made and its satellites are now referred to by the scientists as the miniature solar system. And there's a good reason for that. Each satellite has unique characteristics, from volcanic activity on Io to methane lakes on Liniemi. There's plenty to study on each moon. These satellites are for life to actually exist in the universe. But there is one set of conditions that we believe leads to life, flourishing in its many forms and sizes, and that is the conditions on our planet Earth. So what conditions are these? Water is the #1 ingredient among the list of ingredients required for life as we know it to exist. It's Europa. Satellite photographs taken by the Voyager probe makes it possible to study the structure of ice and confirm that the ice is covered with a considerable amount of salt deposits and heavy metals such as magnesium, which incidentally is the reason for the hue similar to the color of blood. We observe similar conditions on Earth in Greenland, where salt comes to the surface of the ice as a result of volcanic activity. On Europa, however, movements of ice strongly resemble the tectonic activity, indicating they were possibly caused by the ocean. Still, the ice covering this moon reflects a huge amount of sunlight, and the distance to the sun is 6 times greater than the distance from sun to Earth, dependent on oxygen. The so-called anaerobic organisms exist on Earth, and in fact, in the early history of the planet, they were the dominant form of life. The last factor that's expected to be found through further study is the volcanic activity in the crust encircling the core of Europa. In the depths of our ocean, at the border of Liniemi and Callisto, it took almost 400 years before the uniqueness of these Galileo satellites was revealed. In the 1960s, ground-based observations showed that Europa's surface was mostly frozen water, just like most other solid bodies in the outer solar system. At first, Europa seemed to be just an ordinary icy satellite. However, further research showed that the reflectivity of Europa's ice turned out to be incredibly high. This pointed to the fact that the ice was too clear, opportunity thanks to Voyager probes. They photographed the surfaces of Jupiter's moons in great detail.
100 kilometrů. Pro srovnání, nejhlubší místo na Zemi, Mariánský příkop, má hloubku necelých 11 kilometrů.
And it completely changed the scientists' perception of this moon. Indeed, bombarded by meteorites, but on Europa, these traces are either incredibly faint or absent. What do you say to that? The researchers noted that some of the dark stripes have opposing sides that fit together very well, kind of like puzzle pieces. Furthermore, between these cracks, there was some dark icy material that seemed to float. The scientists also found that the cracks they see do not match the predicted patterns that would form as a result of gravitational tides as Europa orbits Jupiter. There was a missing piece of the puzzle. This led to a conclusion that Europa's ice crust was not so solid. It was determined that if Europa's surface moved independently of the inner layers, the patterns would match very well, which would be the case if there was a layer of liquid or slightly warmer ice between the surface and the depth. This spurred the scientists to learn more about Europa, even more intriguing after some research of the Antarctic ice shelf. A new and truly stunning type of snow was discovered there, and it appears the same kind of snow could be falling on Europa. Surprisingly, it seems to fall upwards. How does it work? It's simple. The snow itself is lower in density than salt water, both in the Earth's oceans and on Europa. The relationship between the subglacial ocean and the ice lid during Europa's revolution around Jupiter, namely their friction and increasing temperature, that causes the ice to crack and display those cracks. Ice geysers periodically break out from the cracks consisting of warmer ice or even water. One of these geysers was captured by Galileo. Unfortunately, there was no way to collect samples of this substance. At the same time, it is also important to point out in the process of formation of such cracks, oxygen from a certain picture in our mind, we just need to wait, because in addition to the mission that we mentioned earlier, there will be another journey, and it will be entirely dedicated to studying Europa. Europa Clipper. The mission is scheduled to launch in 2024. NASA has selected 9 scientific exactly what we see. Another useful tool installed on the probe is a radar that will help to determine the thickness of the ice shell of the satellite and find underground lakes similar to those under the ice of Antarctica. A magnetometer on board measuring the strength and direction of Europa's magnetic field will allow scientists to determine the depth and the salinity of its ocean. After the Hubble telescope observed a water plume over the south pole of Europa in 2012, scientists hope that a new ice geyser will be detected during the flyby and that it will be possible to collect samples. The main purpose of the mission is to determine over the course of the planned 45 to 50 flybys if there are places under the ice crust of Europa where life could exist. The more detailed photographs of the satellite will allow scientists to select points of greatest extraterrestrial life could be found. We just have to wait and look forward to new discoveries.
To znamená, že na dně oceánu Europy by mohly existovat hydrotermální průduchy, velmi podobné těm našim. Mohly by chrlit teplo a chemikálie do okolí.
Not so long ago, one of the Reddit threads provided information, just like the story of Voyagers, full of revelations and frightening discoveries. But most importantly, where did it all take place? Where the knowledge about space ends and the theories begin, beyond the heliopause. But let's start at the beginning. How did humanity come to research one of the biggest mysteries of space? And what was the status quo before this discovery?
Můžeme nahlédnout pod desítky kilometrů ledu na světě, který je od nás vzdálen více než 600 milionů kilometrů? Odpověď leží v nové generaci kosmických misí, které jsou již nyní na cestě nebo v pokročilé fázi plánování.
Even though they were made back in the 1970s and your smartphone's processor is much quicker and more efficient, these systems are unique. Their main feature is that they can be reprogrammed and rewritten indefinitely, which is what scientists have been doing.
Jupiter a jeho 3 velké ledové měsíce, Ganymed, Callisto a Europu. I když jejím hlavním cílem je Ganymed, provede 2 blízké průlety kolem Europy, během kterých bude analyzovat její ledovou krustu a hledat kapsy tekuté vody blíže k povrchu. Ještě ambicióznější je mise NASA nazvaná Europa Clipper. Tato sonda, jejíž start je plánován na rok 2024, je navržena specificky pro studium Europy. Nebude obíhat přímo kolem měsíce, protože radiace v jeho blízkosti by rychle zničila citlivou elektroniku. Místo toho bude na dlouhé eliptické dráze kolem Jupitera a provede téměř 50 blízkých průletů kolem Europy, někdy se přiblíží na vzdálenost pouhých 25 kilometrů od jejího povrchu. Europa Clipper je vybavena sadou 9 špičkových vědeckých přístrojů. Kamery s vysokým rozlišením zmapují povrch v nevídaných detailech, což nám umožní lépe pochopit geologické procesy, které jej formují. Spektrometry budou analyzovat chemické složení povrchu, hledat soli a organické molekuly, které mohly být vyneseny z oceánu na povrch. Klíčovým nástrojem bude ledem pronikající radar. Funguje na podobném principu jako radary používané na Zemi. K mapování ledovcového podloží v Antarktidě a Grónsku. Vysílá rádiové vlny, které pronikají ledem a odrážejí se od hranic vrstev, nebo od rozhraní mezi ledem a tekutou vodou. Díky tomu budou vědci schopni zmapovat vnitřní strukturu ledového krunýře, hledat podpovrchová jezera a možná i určit přesnou tloušťku ledu nad oceánem. Další přístroje budou měřit magnetické pole s mnohem větší přesností než sonda Galileo, což potvrdí hloubku a slanost oceánu. Mise bude také hledat gejzíry vodní páry. Pozorování z Hubbleova vesmírného dalekohledu naznačila, že z některých oblastí Europy mohou občas tryskat obrovské výtrysky vody z oceánu do vesmíru. Pokud by Europa Clipper dokázala proletět jedním z těchto gejzírů, mohla by přímo analyzovat vzorky z podpovrchového oceánu, aniž by se musela provrtávat ledem. Mise jako Její a Europa Clipper nám poskytnou neocenitelná data. Řeknou nám více o tloušťce ledu, o složení oceánu a o geologické aktivitě. Ale ani oni nám nedají definitivní odpověď na otázku, zda je v tomto oceánu život. Komu bude zapotřebí další, ještě odvážnější krok? Budeme muset na Europě přistát. A nejen to, budeme se muset dostat skrz led. Představte si budoucí misi, která je zatím jen na rýsovacích prknech inženýrů. Přistávací modul, lander, opatrně dosedne na ledový povrch Europy, přežije extrémní chlad a radiaci. Poté uvolní autonomní sondu, takzvaný kryobot. Bude to v podstatě jaderným reaktorem poháněná krtice, která využije teplo k roztavení ledu před sebou a pomalu se bude nořit hlouběji a hlouběji. Tato cesta bude trvat měsíce, možná i roky. Kryobot bude sestupovat skrze vrstvy ledu staré miliony let, analyzovat jejich složení a posílat data zpět na povrchový modul. Bude to jako vrt do prehistorie jiného světa, záznam o srážkách s kometami a změnách v Jupiterově soustavě. Kilometr po kilometru se bude propadat tmou.
Is life possible anywhere other than our home planet?
Jednoho dne
And what if we tell you that there is a place within the solar system where we can find an ocean full of water twice as large as any of the Earth's oceans? This ocean is hidden under a layer of ice dozens of miles in thickness. However, 125-mile geysers push their way up from under this ice shield, and the atmosphere of this world the ice on Europa. And one of them comes from a similar situation on Earth. It turns out the double ice ridges and cracks visible on Jupiter's satellite are similar to those in Greenland. These irregularities are the potential evidence of the existence of liquid water under this ice. On Earth, such ridges are caused precisely by the presence of water cushions within the ice and under these breaks, which gave the scientists the idea that these cracks are similar to the ones on Earth. As for the chemical elements necessary for the creation and maintenance of life, it turns out they are present on your life forms alongside various cores. It is believed that Europa's rotation around Jupiter causes the same processes at the bottom of the Moon's ocean. And if so, it is possible that life can be found near these hydrothermal zones. And so, we have all the necessary ingredients to create life. Now let's see why we can so confidently claim the presence of these conditions. After the discovery of Europa and its relatives, the satellite's Io large impact craters indicates that Europa's surface was
Pak musí
relatively
existovat na
young.
miliardách dalších
At the
světů
same
po
time,
celé
this means that
galaxii.
something
Stali
had
bychom se
erased the
součástí
traces of any
obrovské
impacts.
kosmické biologie. Samozřejmě,
There
je
are
zde
two
i
possible
možnost,
ways to
že
explain
pokud
this.
najdeme život,
As they
bude mít
escape from
stejný
under the
původ jako
crust,
ten náš.
the streams of
Teorie
ice
panspermie
erased the
naznačuje, že
traces
život
of the
se může
meteorite
šířit mezi
hits, or
planetami, například
the
na
ice
kuse
sank
horniny,
under its own weight
vyvržených při
along with
dopadu
any
asteroidu.
traces of the impacts.
Pokud by
In both
mikroorganismy
cases,
na
it means
Evropě
that the
měly stejnou
icy
DNA
surface is
jako
very
my, to
dynamic,
znamenalo by to, že
almost
jsme
like
všichni
there's a
vzdálený
warmer layer
příbuzní,
underneath,
potomci
forming the same
společného
kind of
předka z
mountains
dávné
as on Earth,
minulosti sluneční
but
soustavy.
upside down.
I to by byl
The next thing
ohromující
hinting at
poznatek,
activity under the
ale
ice were the
nejvíce
geysers
vzrušující
bursting
je
from
možnost,
under the
že by
crust.
život na
Over the
Evropě
past 10
byl
years,
založen
they've been
na zcela
recorded
jiné
3
biologii,
times by
s
scientists.
jiným genetickým
These are
kódem,
bursts of ice
jinými
reaching at least
proteiny, jiným
125
způsobem
miles in height, according to
Byl by to
calculations.
skutečně
How does
mimozemský
it
život,
happen?
který by nám
Scientists
otevřel
estimate that
zcela
the
nové
depth of
pole
the
pro
ocean is
studium a
about
pochopení
35 to
toho,
65
co život
miles,
vlastně je.
and the thickness of
Cesta
the
k
ice crust
odpovědím je však
above it is
dlouhá
about
a plná
12 to
výzev.
20 miles.
Inženýrské překážky pro
It is
přistání a
precisely the
provrtání
relation
se ledem
Europa's
jsou
rarefied
obrovské.
atmosphere.
Finanční náklady na
By
takové
collecting
mise
these
jsou
samples, scientists will be able to
a
study
riziko
the satellite's
selhání je
chemical
vždy
composition in more
ale
detail,
touha po poznání,
painting a
touha
comprehensive
odpovědět
picture
na tu
of
prastarou
Europa
otázku
as a whole.
nás žene vpřed.
This will probably
Hledání
eliminate
života
the
na
need to
Evropě
drill through
není
the
jen
ice and
vědeckým
extract this
Je
information
to
on the
hluboce
next
lidské
mission.
úsilí.
It is expected that
Je to
once the
projev
probe
naší
reaches its
zvědavosti,
destination
našeho
and begins to
odhodlání
revolve
prozkoumávat
around
neznámé
Europa in
a posouvat
2030,
hranice možného.
the equipment
Je
will
to
be
cesta,
able to
která
do
nás
more
nutí
than just
přemýšlet
understand
o
the
našem vlastním
composition and
původu,
structure of
o
the moon
křehkosti
in
našeho
detail, as
světa
claimed
a o
by
našem
NASA.
místě v kosmu.
The user
Tam
also
venku,
said that the
v
probe
mrazivé
registered some
temnotě
mysterious
obíhající kolem
humming
plynného
sound,
obra,
which
leží
reportedly
svět
contained
ledu
a
a
message
tajemství.
in Morse code.
Svět s oceánem
When they
větším než je
decoded
ten
the
náš,
message, they
skrytým pod
recognized the
neproniknutelnou
sounds from
sůl.
the golden records
Možná
played
je
on
to svět
repeat,
tichý a
as if
prázdný,
someone or
nebo
something
možná,
found
jen
the
možná,
probe
v
and was
jeho
trying to
temných,
communicate.
věčných hlubinách se něco hýbe. Něco žije a čeká na to, až to objevíme. Naše cesta teprve začala.
NASA has not commented on this story. The story itself is pretty